So our notes are going to be on angles. And this comes out of lesson 1-4, and today's date is very good, it's the 10th of September, which makes tomorrow September 11th. So you know there's going to be a little bit of probably a moment of silence tomorrow. Okay, so what on earth is an angle? An angle starts from someplace, right? And it continues infinite. What else do we know that starts from someplace and continues infinitely? A ray. So since our angle has to have two sides, it's going to be made up of those two rays. Okay. So we've got a figure formed. By two rays that have the same endpoint. Sides are the rays that form, that is a word, and it would be sides of an angle, is its full word that you're going to use, are rays that form the angle, or an angle. And the place where the rays meet, what's that called? Say again? Vertex. Yeah, they form a vertex. See, letter V? Yeah. So the vertex of an angle. So notice 3 vocab words. Is the common endpoint of an angle. And if you want to, you're more than welcome to, when I take notes, I abbreviate things a lot. I try to remember not to do it with you when I'm giving notes, especially the first time I'm giving something. But you can abbreviate endpoint. I usually do ENDPT. And then angle, I do a symbol of an angle. So feel free to, do your notes as you need to. So just to illustrate those 3 pieces, we've got an angle. It would be, its sides would be ray BA, because remember we start from the endpoint, and ray BC, and the vertex would be C. Now, we need to figure out how to name an angle, and do you guys remember how to do that from... Gosh, it's been a while. How do you name an angle? Colleen?
You use the 3 points on it?
Yeah, you can use any 3 points, but there's a stipulation as to the order. There has to be what letter would be in the center, and this is really important. Isabel? The B. Oh, I wrote C, sorry. Sorry. I wrote C. That's the vertex is B. So when we name an angle, we have to put the vertex letter in the center. Now, if I have a standalone angle, meaning I don't have any other angles coming out of that vertex, then I can just call it by the vertex name. So it depends on what the diagram looks like. So in the example here, I could name it as angle B. So I'm going to use a symbol, and it's an angle symbol, shocking, I know. Okay, I could also name it by 3 points with the vertex in the center. So I could call it angle ABC if I wanted to make sure there was no confusion. And I could also rearrange those letters going the opposite direction and make it angle CBA. So that's how we name angles. Okay. Colleen.
How do you spell vertex?
VERTEX. I know that. Does that look like a V? Vevtex?
No, it's called vertex.
No, here. It's a little tricky sometimes with a stylus. I wish I could find a stylus that looked like a pen so you could have a sharper image, but I know they probably exist, but I don't have the kind of money for it. All right, so let's talk about, If I was going to measure an angle, what would be the unit of measure for an angle? Degrees. So degrees is the unit of measure for angles. So there's me using my abbreviation. And does anyone know what it looks like? You saw it on last night's homework. Aiden, you remember? What does, yeah. It's an open circle high up. Okay, so that's the degree symbol that we use. We don't write out the words. Okay, and next, can I move? Are we good? Shifting. Oh, do you need glasses?
Oh no, I'm just looking. Is that like the angle sign and an S at the end?
Yes. I'm telling you, I abbreviate. Told you I was going to do it, now I'm doing it. All right, here we go. Ready? So the next thing is we have a tool in our arsenal that allows us to create angles. No, not a compass. Protractor. And a protractor not only allows us to create an angle, it allows us to measure an existing angle. So it's a tool that allows us to create or measure angles. Okay. And how I signify between an object angle and the measure of the angle is I write M angle, let's say ABC, is equal to 40 degrees. So that is the measure of angle ABC is 40 degrees. That's how I read that. So remember, we have a different way to write what the object's called versus what its measure is. Okay, so we have to add this one we have to add a symbol. It's funny with the segment we take away the symbol. Okay. All right, so we have 4 types of angles. Let's see if anyone can tell me one of the names. So Drake C. Stop right there. Okay, I'm just going to ask for names, and then you can go back and help me tell me about them. Cassie, give me another one. Obtuse. Georgie?
Straight.
Straight, good. Most people forget about that one. And Nachman?
Right.
Oh, right. Okay, those are the 4. Okay, all of them have a value that's somewhere between 0 and 180. Each of those has a specific portion between 0 and 180. And if you notice on your protractor, it goes from 0 to 180. And most of your protractors go 0 to 180 in both directions. 0, 180, 0, 180. So it doesn't matter what direction your angle is facing, you can put the protractor down and be able to measure. So the first angle is acute. And how I remember him is he's a little cute angle. And when you say that to somebody, you usually want to pinch their cheek, so you're always doing this kind of, ooh, he's so cute. Can't help yourself, so it's a little small thing, right? And so he is going to be an angle measuring between 0 degrees and 90 degrees. Now, the word between in mathematics means do not include the numbers I give you. It's right after 0 and right before 90. Okay? So 0 and 90 cannot be considered acute. Okay? Next angle you guys told me was obtuse. And obtuse is an angle measuring between 90 degrees and 180 degrees. So again, 90 and 180 are not obtuse angle measurements. It's just after 90 and just before 180 is the range that I have. Now the next two angles have no range. They have only one specific measurement for each one of them. So we have the right angle. Actually, Georgie said straight, but we'll go with right. Sorry, I went out of my order here. And a right angle is an angle measuring exactly. We do have absolutes, 90 degrees. And now back to Georgie's. I'll give her a pretty pink. We had a straight angle. Which measures exactly 180 degrees. Now I am a stickler about labels, so if I'm asking you for the measurement of an angle, if you don't write the degree symbol, I will take off points. The textbook gets lazy and doesn't do it often, so don't follow their suit, follow mine, okay? So yesterday we learned about some postulates about segments. So we've got the sister postulates about angles. So the first postulate we learned about yesterday, everybody good with this? Can I move? Okay. The first angle we talked about yesterday was, or the first postulate was the ruler postulate that said blah, 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 blah. And we said, oh, I can use a ruler to measure the lengths of segments. And we were very happy with that. The one for angles is worse, for the protractor postulate. Wait till you hear this one. On line AB, in a given plane, choose any point O between points A and B. Consider ray OA and ray OB and all the rays that can be drawn from O on one side of line AB. These rays can be paired with the real numbers from 0 to 180 in such a way that A, ray OA is paired with 0 and ray OB is paired with 180. B, if ray OP is paired with X and ray OQ with Y, then the measure of angle POQ is equal to the absolute value of X minus Y. In other words, they just told you how to create a protractor. So we're going to take that and we're going to change it. And because it has a name, that gives us a little bit more freedom. Remember, stars means you're going to put the card in that other pile. This is postulate 3 because it's the third one in our book. And this is called the protractor postulate. So in any kind of proof, we would be just saying its name. We would not have to write it out. And we're going to change it to say, we can measure the size of an angle using a protractor. And again, if you really just kind of look through the actual protractor postulate, it just really tells you how to create a protractor. That's it. Okay. Now, yesterday we talked about the segment addition postulate. It says if we have a segment and there's a point in between those endpoints, that the two little segments that are created, if we add them together, gives me the big segment. We have the same idea happens with angles. So this one also has a name, and we use it a lot. So this is our postulate 4, since it shows up 4th in our book. But its name is the addition, angle addition postulate. Very good. Very good. Deductive reasoning. Oh, sorry, I forgot a word. Angle addition postulate. Because we're adding the two angles together to create the big one. I sometimes refer to postulates as the duh ones because it's like, well, duh, yeah, that makes sense. Okay, but so Now, again, we have to write it out, but we'll draw a picture of it. And that's one thing that I like to do always is to go through each of the theorems, add a picture to it, make sure we understand it. Because a lot of times it just sounds like Charlie Brown's teacher's voice, right? Wah, 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 wah. And you're supposed to figure out what you can do with it, okay? So if point B is on the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. Now, there is a second part to this, so we're going to just talk about this, draw an illustration of this first, and then we'll go to the second part. So basically, here's your angle AOC. And then you have somewhere out here a point B. So what they're saying is you could actually kind of connect, and now you've created two little angles. So I'm going to put little numbers on them. So this is a way that we tend to also see things. So this is angle 1, and this would be angle 2. So it's really nice in our diagrams if they use numbers, because then it's a lot easier to identify your angles than having to use all the letters. So another way of writing this is saying that the measure of angle 1 plus the measure of angle 2 equals the measure of angle AOC. Now, the second part to this postulate deals with a special situation that occurs. What if the angle AOC is a straight angle? Well, we know what a straight angle measures, right? What does it measure? 180. So now we can change what we get a little bit. So if angle AOC is a straight angle, and B, so we have a stipulation, point B is not on that line AC, then we can say this relationship exists. The measure of angle AOB plus the measure of angle BOC is now, instead of saying the measure of angle AOC, since it's a straight angle, we can say it just measures its value of 180. Now again, notice that I'm not using the symbol, degree symbol. That's because we're just talking about it, but anytime I give an answer, I need to put it in. So just to draw a quick picture of that one. Okay, so now I've got a straight angle, and we can call these, again, we can name them angles. And we can again say the measure of angle 1 plus the measure of angle 2, because it's a straight angle, has the special equivalent of 180. Can you see that? Okay, like, sorry, I have big hair today too. It's kind of a double whammy. 3 more vocab words. Thumbs up if you guys are ready to move on. Okay. Knocknan is still writing. No pressure. Oh, we got double thumbs going. Man. Oh, she's done. Ready? Here we go. Bam! Congruent angles. Oops, yuck, red. Okay, so we've got congruent angles. So just like we had congruent segments, we can have angles that are congruent. Another vocab word. Angles that have equal measures. That's an E. Equal measures. And so for an example of that, and because I only have one angle coming out of here, all I really need to know is the vertex. So that's angle R. Doesn't matter what the angles look like. If I'm told the number matches, then I know that the two angles. So I know that the measure of angle R is equal to the measure of angle S, and therefore angle R is congruent to angle S. Okay, so those two relationships are interchangeable. We also need to understand the notion of angles that are adjacent. If I'm adjacent, I'm next to, there's not a gap, I would be touching. Okay. So adjacent angles are two angles in a plane. They emphasize that phrase in a plane because they need you to know that there's multiple planes, but these are together in the same plane. So two angles in a plane that have a common vertex and a common side. But don't overlap. That's the key. So angle 1 and angle 2 are adjacent angles. I think that was the bell. Okay, there's one more word I'll put up on here. I'm going to pause this. Okay, the last word we have is for a bisector of an angle. And the bisector of an angle is like a midpoint of a segment. So it's the ray that divides an angle into two congruent, adjacent angles. So remember, adjacent means they have a common vertex, a common side, but they don't overlap. So let's do an example of that. Call this. So in this diagram, even though it may not look like it, we've got angle XYZ, and there is a ray YW that breaks the angles into two halves. So from this diagram, we can get a couple pieces of information. First, I know that the measure of angle XYW is equal to the measure of angle WYZ, because they both equal 30. And because I have two angles that have the same measure, that means those two angles are congruent to each other. And because I have created two angles that are congruent, I can conclude that ray YW bisects the angle XYZ. Okay, a lot of information just from one thing, and I can use that when I'm trying to set up problems and solve them. One more thing to share with you guys is when you're looking at diagrams, you're going to see some little marks. So just to give you an example of that, let's see. We'll call this point A. We'll call this point C. This we'll call B. We'll have a ray coming out of B. We'll call it ray BD. And if you see some tick marks, I think often they're red. those tick marks represent that you have congruence going on. So that's basically telling you that segment AB is congruent to segment BC. All right, good luck.